Hey, how's it going? This is Mr. Murray coming to you with a little video covering the quiz that we just recently took in Course 2 Honors. This quiz covered similarity and dilations, and so the two big concepts were mostly, I would say, dilations, so taking shapes and stretching them and shrinking them around a point, both the origin, 0, 0, a point within the shape. So for example, here on ABC, for example, 1, 4 is inside the shape, and a point outside the shape, such as in this diagram you see here, negative 4, 2. That's outside of both shapes right here at negative 4, 2. Okay, so we have to be able to execute that, and we have to be able to do that with a scale factor that expands or stretches the shape, one that's more than 1, and one that shrinks or compresses or pulls in the shape towards the point, and that is a one where you have a dilation factor between 0 and 1. Okay, if you are still really struggling with dilations, what I need you to do is go ahead and take a look at the dilations video. So I'm going to link to it right now. Okay, you should see a little thing come up above at the top of the screen. If you still are struggling with how to do dilations, I need you to check out that video, because that video talks about all three different scenarios. Okay. All right, so I'm going to start going over this, and as we go, I do want to say that if you don't do the same thing as me in some of these problems, and I'll try to indicate that whenever possible, it doesn't mean your answer was wrong. All right, some of these have more than one solution, and that's completely okay. All right. All right, and speaking of which, here's our first example right here. So I have a triangle ABC, and after two transformations, it has become triangle A double prime, B double prime, C double prime. I need to describe the transformations that are performed in order, okay, as in the order matters. And then if I have a point that's on the shape of ABC, what would the formula for the coordinates of the corresponding point on the image, A double prime, B double prime, C double prime, be? Okay, so quickly to talk about how we did. I would say overall good performance on this question. The only thing that I would probably look out for to be careful with, particularly in A, is if you talk about doing a rotation or you talk about doing a dilation, you need to mention the center point of that rotation or dilation. Okay, because if you think about it, if I say rotate 90 degrees in this shape right here, in this graph that you see, how would I know where I'm rotating about, right? Because if I rotated about 0, 0, this shape ABC, that's a lot different than if I rotate around negative 3, 3, okay? This point over here, I'd get a completely different shape. So I need you to remember that, and please, when you're doing, and same thing with dilation, if I had this 0, 0 with a scale factor of 2, all of these would shoot out this way. But if it was here with a scale factor of 2, B would shoot out this way, C would shoot out this way, A would shoot down that way. Okay, so it's important. Those details are important, and so if you left those out, you did not get full credit. Okay, so here's an example of these transformations in order explained. Okay, so I have ABC right here. One thing that I could think to do is I like to do the rotation first. Okay, so I'm going to come down here and I'm going to think about 0, 0 as a good center of rotation. Okay, so I'm going to take this shape and I'm going to go ahead and I'm going to try to rotate it. I don't know, looks like we should rotate this thing probably 90 degrees, maybe counterclockwise, or right, counterclockwise about the origin. Okay, let's see what happens if I do that. So what happens is A comes down to here. If you turn your paper right now, turn your head, you'll kind of see that A went to negative 2, 1. Right? So we talked about rotating and then redefining. C, again, tilting my head, I get negative 4, 2. And B, I get I get 6, negative 2. So that's somewhere over here. Okay? All right. Now, how do I get this? So this is basically B prime, C prime, A prime. But how do I get this down here? Well, look, I know that this is clearly shrunk. So that means that I need a scale factor of less than 1. Obviously, between 0 and 1, we don't have a notion right now of negative scale factors. We've been working with positive ones. All right. So in any case, regardless, this is smaller, so my scale factor has to be between 0 and 1. Now, if I'm going to pull everything in towards the center, notice that if I use a scale factor of a half, okay, notice that now B double prime is half as far from the origin as B single prime, right? For B single prime, I go over 6 up 2. For B double prime, I only go over 3 up 1. So see, over 6 up 2, 6, 2, 3, 1. So this is half as far from the origin as this. C, this is over 4 up 2. This is over 2 up 1. So now C double prime is half as far. And now I get the same thing with A prime. So when you dilate with the center of dilation being the origin and a scale factor of a half, now it pulls on top. So it's one option. Second option I actually really liked people doing, and I thought this was okay. I think I saw someone maybe rotate about A to get it to flip around. I thought that was a pretty cool suggestion. I had some people do the dilation first. Okay, so to dilate by a factor of a half. Okay, so for example, if I dilate by a factor of a half, in the first step, A comes here, C comes here, B at this stage comes here. Okay, so this is dilation first. Sorry for my rough graphing. Then I do the 90-degree rotation, and it will go on top. Okay, so there's two ways to do it. Okay, the first way I'll show in red. This is rotate 90 degrees counterclockwise about the origin. So if you get your quiz back and I said about with a line, that means you didn't specify the point to rotate about. Okay, and it's really important that we're mathematically precise there. Okay, and then dilate. You gotta just dilate with scale factor 1/2 and center of dilation 0, 0, or you could say the origin. Either that would have been okay. So other way we could have done it is we could have done a dilation, okay, with scale factor 1/2 and center 0, 0. That pulls it in, and then rotate 90 degrees counterclockwise about 0, 0. Okay, that makes it clear not only the amount but also the center, and the center does matter. Okay, so here's how you would do this. Okay, and basically it doesn't matter how you do this. I'm going to show you with the red. So if I rotate, so here's how I do this. I want to rotate 90 degrees counterclockwise about the origin. I'm doing this, so I'm going from this to this black triangle right there. So look, some of us learned the rules in a previous year, some of us didn't. Okay, the thing is, and again, what I really kind of tried to spotlight in class is that some people, just by looking at it and taking the time to write out the original and the new points, were able to find a pattern. Okay, you gotta be persistent here. Okay, so this, for example, is the point 2,4. This is the point -2,6. This is the point 1,2. Okay, in the end, it ends up at -4,2. A ends up at -2,1. B ends up at -6, -2. So let's think about the rule. What happens here? If you don't know the rule, take a look at the new numbers. See the pattern? All that's happening is that the x's and the y's are flipping, but then we're taking the opposite of whatever the x is, in the new point. So in other words, if y is a negative, it becomes a positive when you flip it to the x coordinate. And if it's a negative, it becomes a positive, and a positive, a negative. So see, the x turns to the y, and then you take the opposite. Okay, so if I have a formula x, y, what happens first? The y comes over, but the opposite of it as the new x, and the x, so basically it's almost like they flip. Okay, now we have to look at the dilation. So what's happening with the dilation? Well, look, the new point A becomes the new C double prime, essentially. So this is the same thing as C double prime, but this becomes -1, -1, 1/2. So what happened is cut in half, cut in half. This becomes -3, -1, cut in half, cut in half. So if now I want to find the coordinate, what I need to do is I need to take half of the y, and maybe let's do this in red because this is the red triangle. So that becomes instead of -1, -1/2, and there's what the x becomes. Okay, so that's the rotation followed by the dilation. If you do the dilation and the rotation, you get the same thing, because the dilation would go like this. So look, notice these are all half, 2 and 4, 1 and 2. -2, -6, -1, -1, 3. So here, the dilation first, you're cutting them in half. Then you're doing the rotation. The rotation flips that 1/2 y becomes the x, and this x pops in and becomes the y. So see the exact same formula either way. Now remember, there could have been other ways to do it. As long as you got one shape to go on top of the other, you did get full credit for A, and you were clear with the transformations. Outside of that, very difficult to give you full credit, because unless you're able to come up with the correct conversion or an equivalent. So I'll take a look for that. Okay, so please make sure you understand this first problem, and then in a moment I will move on to the next one. All right, here we were just doing 3 dilations with the same 3 points. Okay, so I have ABC. This is, I'm saying, a different triangle from the one above, right? Up there, up top in problem 1, we had ABC. This is just a new ABC. Okay, so I'm going to dilate it 3 times. One is going to make DEF, one is going to make GHI, one is going to make JKL. Now, one thing I didn't see enough was marking these problems up. So I need scale factor 2, center 0, 0, and I need to take ABC and from it make DEF. Okay, so I'm going to write my center of dilation, and let's apply the dilation. So I go over 2 up 6 to get to B. So go over 2 up 6, and this wasn't on the graph, but I think this is something we can reason through, and if you got it in the right place, that was fine. Okay, -4, something like this is fine. Okay, A over 3 up 4, I need to get twice as far away, so you need to go another over 3 up another 4, and now see, this was up 1 over 2, now this is up 4, so up 1 over 2, or up 2 over 1, up 4 over 2, up 2 over 1, up 4 over 2, so twice as long. Okay, so this is D, this is E, no, sorry, this is D, this is E, okay, because you got to be careful of how the letters line up. And now for F, F goes with C, so we got -4 over 2, -4 over 2. And there would be F, okay? And mine's going to look a little bit goofy, and that's because, remember, I'm using the tablet. So there we go, DEF, okay? Stretched by a factor of 2 from the origin, and we can see it's kind of got that blowback effect, -3, -4, 6. Okay, yeah, it's just, I think my perspective is just a little bit warped due to the squiggliness. But in any case, it's getting blown back from the origin. It's almost like, think about it like this. It's almost like if you're shining a light, okay? This is my light. I'm shining the light. It's hitting this object, and then it's getting shown onto the wall behind it, right? If you've ever like put a light in front of something, how it gets really big on the wall, it's like that, right? It's blowing up, it's expanding, it's going to the wall. If it doesn't look proportional, again, it's because this point should really be higher up. But the idea is I wanted to see you do that expansion out from the origin. All right, the second one, and let's just do this one red because we decided to do red. So I'll do the next one blue. Okay, this time I'll do it blue. Here's blue. Okay, now it's dilated by a scale factor 1.5 from center 0, 2. So rather 4, 2. So here's 4, 2. And now I need to scale it by 1.5. So notice I didn't specifically say C, but C is the point of dilation. Okay, so C is not going to move at all because it's getting 1.5 times farther away from C, but C is not, right? The distance between C and C is 0. So getting 1.5 times farther from 0 is 0, right? Its point doesn't move. So C remains as is. Now B. B is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So B is over, I believe, over 4, up 4 over 6. Okay, and so we want to get 1.5 times that much. So 1.5 times 4 is 6. 1.5 times 6 is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. Okay, so notice also it's 1. So if you break it down into these over 3 up 2s, notice it's 1 over 3 up 2, 2 over 3 up 2s away right now. So what's 1.5 times 2? It's 3. So if it was 2 of these over, now it's got to be 3 of these over because it's got to be 1.5 times as far away. Okay, it's another way to think about it. Okay, A, 1, 2, 3, 4, 5, 6, 7, 2. So right now it's up 2 over 7. I need to get 1.5 times as far, so it's got to go over 3, or up 3 and over 10.5-ish. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and a half. 1, 2, 3. Okay, and I can get like super lazy probably and like connect these up. Oh man, that didn't come out well. I can't live with myself on that. Okay, something like that. Hook these up and then it comes right in. It's really a matter of tracing it for me onto C. Okay. All right. So now we're going to talk about the one on the inside. So here's what I'll say. Let me just label this and then here's what I'll say. I do feel that 1 went okay. 1 went great, actually. No problems with A. A was pretty good. B could have been better. Let's take a look at C. C actually went decently, and C actually, for a lot of people, went smoother than B. So now we're going to do a scale factor of 1/2 with a center 0, 4. So the first thing I want to say in terms of this, 100% of people had the intuition to say, look, if it's more than 1, it's getting bigger. If it's less than 1, it's getting smaller. Every single time I saw one of these where the scale factor was like 2 or 1.5 or more than 1, I saw a bigger shape as the result. And every time it was a fraction less than 1, I saw a smaller shape. So that is a good start. It's just a matter of better understanding the center of these dilations. And so what I would want to see you do is actually plot that center out, because for some of the people who did not dilate correctly, many of those individuals did not have the points drawn out. Okay, so now I'm going to do about 0, 4, scale factor of 1/2. Right now, I've got to go over 2 and up 2 to get to B. So I'm going to go over 1 and up 1 to get to the new shape. Here I've got to go over 3, so I'll go over 1.5. Here I've got to go over 1, 2, 3, 4, down 2. So I'll go down 2 and 1, because 2 and 1 is half of 4 and 2. And now I'll connect, connect, connect. And this will be J, K, and L. Okay? So not an easy problem, but again, let's think about what we want to do. We want to be very clear with our work. We want to underline. I did give you room to write things out, so you really want to take advantage of those, and then really take every precaution to do stuff like plotting the points. I don't care if you plot these points, like these dilation points, etc. What I want to see is the triangles dilated. That's what ultimately matters to me. If you need to use that to help you, that's completely fine. Okay, so please make sure you understood what we did here. If needed, go back and rewind and kind of take a look through some things. And then in a moment, we will move on to the next question. All right, so the next question, let's take a look. So this one, everyone more or less got. A rectangle with length x and width y is dilated by a scale factor of 2.5 from the origin. How much larger? It says area now, but it said perimeter on the quiz. Okay, so in terms of this, what we want to do is we want to get the new perimeter. So in the original rectangle, I had x and y. On the new rectangle, I had like 2.5y, 2.5x. So then people noted, well, the perimeter here is 2x plus 2y because it's 2 of these and 2 of these. Well, 2 of these, that's 5x, and 2 of those, that's 5y. So this is 2.5 times larger. Okay? And any kind of justification is good. Now, here's the difference. Here's why I like area better, because the area here is xy. The area here is 2.5 and 2.5, so that's 6.25 xy. So this is 6.25. So instead of just being like, oh, dilation 2.5 times larger, right? 2.5 times larger. Now it's 2.5 times 2.5. So instead of being that like k larger, it's now k squared larger. Okay, and if we think about this, if this was a cube, it would be k cubed larger, right? So this would be, for example, if I had x, right, it would be x cubes. But if it was 2.5x, it would be 2.5 cubed when you did all that out. Okay, so just something to think about. Going on to number 4. All right, what we know is AB is parallel to DE, and we have these triangles. What do we know? Now, many people were correctly able to note that these were similar. I did for next year add in that these figures are not drawn to scale. That was not in the original quiz. Okay, just so you know. So now we need to analyze this thing here. And to do that, let's take a look at some of the things we know. So we know that BC is, we got to be careful here, 24. Okay, and we know that EC is 6. So therefore, given that they're similar and they've got a scale factor of 4. Okay, so I saw two things here. Well, immediately some people said, okay, this was 1.75. Other people said this was 7/4. Either one of those is correct. But now here we have 7 and we have 24 as our two sides. So we know that 7 squared plus 24 squared equals c squared. In other words, if you think about it another way, ac squared. And when you add those up, and this was something we had a calculator to do, you'd actually get that ac squared equals 625. Okay, so therefore AC is actually equal to 25. You could divide that by 4. You get DC. Some people got 6.25. Some people got 25/4. Either one of those was okay. All right, so we have DC, and again, based on the scale factor, equaling 6.25 or 25/4. AC equal 25. That's just using the Pythagorean theorem in a sense. And then DE equaling 1.75. That's just, again, using the proportionality. So these two have the same logic. This one here is the Pythagorean theorem. Okay, so please make sure you understood 3 and 4. Go back and rewind if needed, and then in a moment I will do the bonus problem. All right, On the bonus, lots of different answers. I'll go through a couple that were good. A lot of people did a dilation about this point right here, which I actually never thought of. So they knew it had to be smaller. So they're like, all right, let's do a dilation by a factor of a half, let's say. So I had this came in here, this came half as far, this came half as far. Okay. And if you think about it, we know that these x's, y's being the same can't change, right? Because if you take a number and another number and they're the same, when you cut them in half, right, they stay the same, right? So 4 and 4, they're equal. You cut them in half, you get 2 and 2, etc. Then they go, okay, why don't we reflect over the x-axis? So this comes here, this comes here, this comes here, this comes here. Perfect. Another way, dilate by a factor of 1/2 with the point set with the dilation center at A. So that stays the same. That comes in. This is up 2 over 3. So this would be up 1 over 1.5. And this is a distance of 4. So it pulls back to a distance of 2 if we use a scale factor of 1/2. And using A is a convenient choice because A is 0 units away from itself, so the dilation causes no effect. Okay, then you could do something like a reflection over the x-axis. 1/2, 1, 2, 1, 2 with a half. Okay, 1, 2, 1, 2. And then translate either by the vector 1, negative 1/2, or translate over 1 and down negative, or rather down by a half. Okay, that's another way I saw it done. And it was mainly just a transition of those. Here's one last one that I liked. Someone did this. So first they did the reflection over the x-axis. So reflect over the x-axis, boom, 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 boom. Then dilate with center 3, negative 2, and k value or scale factor 1/2. So this is over 2 up 1. So it's over 1 up 1/2. This is down 2. So it's only down 1. This is more or less down 1 over 2. So I'm going over 1, down 1/2, right? 1/2, only 1 to be half, only a half, okay? And then up to over 2 up 1. So instead of going over 2, I go over 1. Instead of going up 1, I go up 1/2. And now I've got my brand new shape. So lots of different ways you can do this, all right? I hope you found this video to be informational. Again, I think a lot of good stuff coming out of this, but especially for those of you who struggled on this quiz with the upcoming unit test, really important to understand where you did well and where you need to do better, okay? So again, feel free to go back and look at any one of these questions. Thank you so much for watching. And remember, you can do it, all right? Don't give up. Keep loving math and have a wonderful day.